some numbers like 0, 1, -1, 1 over 2, square root of 2, e and pi. As we all know, they're along this line, the real line. And today I want to talk about the story of real line. But first of all, why do we even care? Well, I used to have this thought that math is just an artificial and imaginary world in which smart people play with themselves, but then I read this novel called The Housekeeper and the Professor, and in that, a sentence says, in math, every symbol and every number has its own meanings. And that's true. And that's why we care. On this real line, there are a lot of information and stories we want to know. And we need this language of math to describe and understand the universe. So let's take a closer look. Everything starts from here. 0, the origin. This is fascinating because it used to just serve as a placeholder that simply means nothing, and gradually it became number. And then we learn how to count. Actually, these numbers are probably among the first few numbers we have ever learned in our lives because they're very natural for us to understand. We call them natural number. Here we say natural number starts from 1 and goes to infinity. But some may argue that smallest natural number is actually 0. Well, there are still debates among this question, so probably try to get used to both of them. Okay, now let's focus on the other half of this real line. See this negative sign here? Comes from subtraction. And as we can observe on this line, every number is very clean. There's nothing after the decimal point. Well, you may say it's called whole number, you may have heard of that, but here we give them a name called integer. That includes all the negative whole numbers, 0, and natural numbers. Okay, now let's see something interesting. 1 over 2. Why is this interesting? It's just 0.5, right? Well, what's this line here? Is this just division? Yeah. Every time when we see form of this number, see this line here, that reminds me of how we teach a kindergarten kids how to share pizza or something. And that's how people find these kind of numbers. Well, for all numbers in the form of p divided by q, in which q is not 0, q is a natural number. Well, just to make it easier to understand, but I just want to make sure everyone knows q cannot be 0 since it doesn't make any sense to share anything with nothing, no one. Okay, and p is an integer. Well, that's also intuitive, right? And it makes a lot of sense. For these kind of numbers, we call them rational numbers. Okay. But are integers we just talked about also rational numbers? Well, they are, right? Because we can simply just represent every rational number in the form of itself divided by 1, right? Okay. Now let's see some more examples. Like 1 over 3 is 0.33333. And this bar here denotes the repeating part of decimal. And 1 over 7. 2 over 7. Well, is there a pattern? Actually, all rational numbers can be represented as repeating decimal or finite decimal. And all finite or repeating decimal are also rational numbers. But can you think about why? Okay, think about it and we'll move on. Oh, well, square root of 2, this number is intimidating and it freaks a lot of people. Even the greatest mathematician in history, it freaked them out. But why? We all know square root of 2 comes from this triangle, right? It's 1 and 1. This is square root of 2. And this circle goes here, square root of 2. It seems like a really nice number, right? This triangle makes sense and this circle and everything. But is that special? Well, there's no repeating patterns in decimal, which means we cannot represent square root of 2 in the nice form I just gave, we just talked about. And that's why it's very counterintuitive when people first found this number out. And we call them irrational numbers. All real numbers that are not rational, we cannot represent them in the p divided by q form. We call them irrational numbers. But can we prove square root of 2 is irrational? Do you remember in the beginning we saw e and pi? Are they also irrational? Well, if I have to talk about them now, they're probably irrational, right? But do you know there's a difference between square root of 2, e, and pi? Well, let's see. Seems like we can't observe obvious patterns for any of them. They look really random, right? Okay, I'll just tell you. Square root of 2 is actually the root of this equation. And that's why we call numbers like square root 2 algebraic numbers. Algebraic number is a root of a non-zero polynomial in one variable with rational coefficients. Form like that. You don't have to have a deep understanding of this sentence, but we're gonna talk about this later when you have more knowledge in algebra. And any irrational numbers that are not algebraic, we call them transcendental numbers. Okay, that's all for today, and let's review what we learned. Remember these numbers we just saw? Okay, I assume we're very familiar with the concept of sets. So, we call the set of all real numbers R. And in real numbers, we have irrational numbers who are just not rational numbers. And in rational numbers, there are very special numbers called integers or whole numbers. And inside integers, there are natural numbers. But don't forget, in the end, we learned about two different forms of numbers: transcendental numbers and algebraic numbers. Actually, can we fill in every number we talked about in this graph? Okay, let's start. Square root of 2, which is irrational and also an algebraic number. E and pi are transcendental numbers. They're also irrational numbers. And 1 over 2, it's rational, but it's not an integer. In integers, we have -2, -1, 0. And in natural number, we have 1 and 2 and blah, blah, blah. Okay, so that's the end of the review. Let's move on to some quiz questions. First, we all know pi is defined by circumference of a circle divided by its diameter. But what do we know about the circumference c and diameter d? I'll give you some time, think about it. Well, the answer is D, right? If you chose A, think about the definition of rational numbers, the P over Q thing. Well, if we denote the first rational number P1 divided by Q1, the second P2 divided by Q2, what do we get? Another rational number. But we all know pi is irrational, right? But does C and D have to be both irrational numbers? Not necessarily, right? What if D is 2 and circumference is 2 pi? And then people may have question about E. Does C have to be irrational and D have to be rational? That's not true either, right? They can be both irrational. Like diameter is square root of 2, circumference will be square root of 2 times pi. That's also an irrational number. Okay, cool. Let's move on to the next question. If r is an irrational number and k is an integer, what do we know about x equals r to the k? X is a rational number, x is an integer, x is an irrational number. Or we don't know anything about x. Well, do we know anything about x? Really? What do we know about x? Okay. Well, if r is square root of 2 and k is 2, then sure, x is a rational number, it's 2. And x is an integer, it's 2. But how about pi? What if r is pi and k is 1? Then x is an irrational number, right? So we don't really know anything about x, right? Okay, that'll be all for today and hope this will be helpful. Thank you for watching. And think about those 2 questions I asked in the video.